It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello, everybody, and welcome to another episode of Pure Performance. My name is Brian Wilson, and with me is my co-host who's really trying hard not to mock me right now, Andy Grabner. You know what's special about today's episode?
What is special about today's episode? Looking at our faces, the three faces, I see a progression in a lot of hair, receding hair, no hair.
That I hadn't thought about that one, but it's our 175th episode.
Wow.
Yes, very interesting. And the thing that amazes me about our 175th episode is it's one of these topics that when you first look at it, you're like, really? That's what we're going to talk about? How does that have any relevancy in today's world, right? But that's what we're here to learn today. And based on some of the prep for the show, holy crap, yeah, quite a lot of relevancy. So I'm really excited to get into it. And I thought, I'll let you do a magic segue like you normally are. But I just got to say right before we start, for as soon as you hear the topic, don't run off, people, because it's a heck of a lot more exciting and relevant than you could possibly even imagine. And I'm excited, and I know I'm going to learn a lot today.
Me too. And it's like when you said 175, it's like Back to the Future. I'm not sure if that makes any sense now with this reference, but we're kind of in the future. We're looking back, with the movie. Yeah. But we're talking after 175 episodes, we didn't progress into future technologies, but we're looking into technology that actually makes all the stuff possible that works today. Looking at my phone, if I make a bank transaction, I'm pretty sure
it's not a bad segue, Andy.
It's not a bad segue. It probably hits the mainframe. And now we finally give our guest the chance to introduce himself. Christian, so sorry that it takes that long for the two of us to actually give the mic to you. But Christian, thank you so much for being on the podcast. Could you do me the favor, Christian? Introduce yourself, who you are you, what do you do? And why are you excited about the mainframe, which is the main topic of today?
Okay, thanks, Andy, for having me on the podcast today about mainframe. Christian Schram from Dynatrace in Austria, located in the Linz lab. I'm working at Dynatrace for 23 years now, and I have a very strong mainframe background. I'm working in that space for almost 30 years. And starting out as a mainframe developer, systems programmer, I worked as a performance analyst and consultant. And in 2000, I joined Dynatrace, and I'm working with mainframe customers globally, with a focus on Europe, of course, as I'm located here, but I'm working also with customers overseas. Mm-hmm. And I'm an interface between the field, our sales organization, our solution engineers, and the lab, the product management, and give feedback regularly. What is needed on the market, which technologies are hot on the market out in the field, and what do we actually need to further improve our solution.
Mm-hmm. Now, I'm pretty sure.
Before we go, I got to ask a question, because there's something I just learned there, or maybe because it really confused the heck out of me. Christian, you said you've been with Dynatrace for 23 years. That is news. Was that by way of CompuWare, or because I know Dynatrace product-wise came in around 2006 or 7, at least as far as I know. Was Dynatrace the actual company started from like development and stuff in that time period, or was this were you coming in from CompuWare?
Yeah, you guessed it correctly. I'm coming from CompuWare. So in 2000, originally I joined CompuWare, which was then which acquired Dynatrace in 2011. And then I moved over, made the transition to Dynatrace.
Okay. Mm-hmm. I thought correct. It was like, holy cow, because I I thought the actual inception of the OG Dynatrace was way back then. I was like, I had no idea. So needed to clarify that for myself. So sorry for cutting you off, Andy. I couldn't let that one rest. My mind was exploding there.
Yeah. Christian, we probably have a lot of listeners that are looking at some of our previous podcasts that they listened to, and we talked about DevOps, we talked about SRE, we talked about serverless, we talk about all sorts of, as you said, future trend technology or stuff that is currently hot, microservices. How does the mainframe still fit into this picture? I mean, is this, and this is the interesting thing, right? We never think about that these technologies actually still power so many of our services we use on a day-to-day basis. I said earlier on my phone, when I make a bank transfer, I'm pretty sure it hits the mainframe. So to rephrase the question, Christian, for the people that never thought that the mainframe is still a thing, and that it's relevant for them in their day-to-day life, that they're actually interacting with it, can you give us first maybe a quick history, a little bit of an overview where the mainframe come from, and also answer why is it still relevant in the applications we're using today? That would be an interesting kind of segue that you could make.
Yes, definitely. Yeah, the mainframe, as you said, it has a strong history, a long history. So the first mainframes were introduced even before 1964. But the really revolutionary mainframe platform was the IBM S360 that was introduced on April 7, 1964. So very important date. So almost 60 years ago. And that really revolutionized the IT industry. So the development cost for IBM for that specific platform was around 5 billion. You have to imagine that's really an amazing figure. So today, I would guess that would be equal to 40 billion or something like that. So really a massive figure. And yeah, it developed over time. More and more technology stacks were added, and Java was added as well to the mainframe with new processor types reflecting that are able to run on these processor types. So the mainframe was set dead already in the early 90s when I started working on the mainframe. But hey, after 30 years, it's still there. It's still important. And as you mentioned, it still runs business critical transactions on the back end, not only banking transactions. I think almost 90% of credit card transactions are processed on a mainframe backend. So that is really an impressive figure. Not only, I would say, traditional applications are running on the mainframe, but also newer technology stacks like Java-based technologies, even OpenShift, can be run on a mainframe. And yeah, these older technologies like COBOL and PL1 applications that have grown over 40 years and have been developed over time are still made available to the outside world with different technologies. So that is really an important topic today, to make these old assets available to the outside world. Recently, I worked with a customer who is calling mainframe transactions from AWS Lambda services. So that was really impressive for me, how easy it is to make these assets available to the outside world. So cloud meets mainframe here, old stuff meets new stuff. And yeah, the mainframe is still important and is running a lot of business critical transactions nowadays. And the more important it is to make it available to the outside world, and also have observability into these mainframe assets.
Mm-hmm.
Yeah. I just want, before we could move off of this topic here, I wanted to ask, I imagine it would also be very important to continue to educate people about mainframe. And right, everyone's going into front-end development, back-end development, all these, fancier code bases. But I imagine that there is quite some trouble hiring younger generation people into mainframe operations, learning COBOL, learning how to even use and interact. I can imagine a lot of aging out of the workforce who knows how to work with mainframe, and that's probably another issue going on there. And yeah, I mean, because when you think about mainframe, right, you're talking about, if we go back to the old ones, right? If you look at the old science fiction movies, those are the ones with the large tape reels spinning around and all the little beeping lights. And well, I guess they probably didn't really beep. They beeped in the movies, right? But obviously they're much different these days. But it's, yeah, I can imagine that's another big part of this too. Anyhow, I didn't want to sidetrack, but just to throw out to people out there, especially if you're not happy with where you're at now, you probably have a good longevity job in mainframe.
Mm-hmm.
Yeah, you say it. Nowadays, this becomes more and more of an issue, of course. Old mainframers are retiring, so there's a skills gap, definitely. But organizations already started to reflect that and educate people inside their organizations. So I recently met a systems administrator of a big insurance company, and I really was surprised that this was a 30-year-old guy. He was educated in-house and is now responsible for business critical IMS systems of this large insurance company. So, yeah, there's a reaction already, but still there's a lot more to do. A big problem is, of course, that COBOL PL1 normally is not taught anymore on universities and schools. I know that there are some schools who do it again, I would say, but there should be more, of course. But as you said, it's a big problem, and organizations need to react appropriately to fill that skills gap.
Talking about COBOL, it just reminds me, and we probably need to redo the screenshot later on, our picture, because I just, over the weekend, I was at my parents' house and I was digging through some of my old stuff, and I found the old COBOL programming book, the handbook that I got in my high school, because when I was in high school in the 90s, we learned COBOL. And back then they also told us, right? Yeah, we're not sure, but I think the mainframe will not be relevant anymore when you're finished with school. But as you said, 30 years later, it's still very, very, very relevant. Christian, I have a question. Because as Brian said, when I hear mainframe, and many maybe hear mainframe, they say, well, this is old hardware, old computers, but it's actually not, right? I mean, I assume there is new hardware being developed. There is also new operating systems. Is there still innovation, quote unquote, going on, or is it more on making sure that the operating system is optimized for the latest hardware? Because obviously hardware needs to be renewed, and I guess they're building new pieces. They're optimizing and making it more efficient. Is still happening on a regular basis by IBM?
Yes, definitely. There is new development concerning OpenShift with acquisitions. IBM definitely also wants to bring new technologies also to the mainframe. And with the acquisition of Red Hat, of course, OpenShift on the mainframe is a big topic, and more customers are using that as well. So there is new development and new technologies coming on the mainframe platform. And yeah, of course, the operating system needs to reflect that as well. And yeah, the new technology, of course, is a big topic for IBM as well.
Yeah. But let me ask you a question then. If OpenShift and also Java, you mentioned Java earlier, I can run OpenShift and I can run Java on the mainframe. Why would I pick the mainframe? And why would I not run it on some virtual hardware somewhere or in the cloud? Why do organizations choose the mainframe?
Typically, it's organizations that already have a mainframe. So if they have some traditional applications, they also go down that route to include also these new technologies on the mainframe because it's easy to achieve. And IBM has done a good job in the past to make these new technologies more attractive for customers. So if we think about the introduction of the SAP processors, which are now SIP processors, it's some specialty processors that have a fixed cost, and Java workload can be shifted over there and is more cost effective for mainframe customers. So that also closes then the skills gap because Java developers are easier, I say cautiously, easier to acquire than COBOL and PL1 developers. But yeah, IBM has done a good job to make the mainframe more attractive also for these new technology stacks.
But you're not necessarily getting the speed benefit from the mainframe for languages like Java, correct? I mean, I only asked with one bit of context that I had way back. I was working with a financial company, and they were writing all of their code in C or C++. I forget which one, because basically Java and .NET, because it was like a high-speed trading platform. From just a code execution point of view, we're too slow for that volume. So it's not like you're going to get like mainframe can run things really fast and really high volume. But languages have a limitation of their own, correct? So you might get a little benefit from the mainframe, but you're not going to get that full throttled mainframe speed with more of a heavy language like Java. Is that correct?
Yeah, so sorry to interrupt you, but that was probably an issue in the past with the first releases on Java on the mainframe. Nowadays, with these modern WebSphere application servers or Liberty servers running on the mainframe on these specialty processors, that's not an issue anymore.
Okay.
A problem, of course, was in the past if you had some mixture of languages, if you were calling Java from COBOL or vice versa, then it could have an impact on response times and resource usages, but that was in the past. Nowadays, that's not an issue anymore.
So that's more that innovation. Yeah, cool.
Yes, definitely. So IBM has invested a lot to streamline the newer technologies also on the mainframe.
Learn something new, Brian. Right?
There you go. This whole episode is new, right?
you had outdated data in your memory. It's like
I sure did.
It's like ChatGPT, because ChatGPT only goes until 2021, and if you ask something more recent, right? But hey, Christian, we talked about, you're on a pure performance podcast, and performance engineering is obviously also relevant for anything that runs on the mainframe. And what we need to do performance engineering is visibility and observability into systems. Can you give us a lay of the land and kind of an overview of how does observability in general work, maybe on the mainframe? What type of data, metrics, or insights do we get? And to do a little bit of a segue into kind of our quote-unquote modern world, does OpenTelemetry play any role in this, which is kind of like an emerging or the standard nowadays when it comes to distributed tracing?
Yes, definitely. That's a topic as well. So when dealing with mainframe applications, of course, it's very important not to only have a very siloed view on the mainframe platform. It's essential to have end-to-end visibility, end-to-end observability to see which applications are calling into the mainframe, which services are hitting mainframe transactions, and that observability is key to understand who is stressing the mainframe platform, because every CPU cycle on the mainframe is associated with cost, and therefore it's in the interest of every organization to reduce MSU usage, which is CPU usage on the mainframe, to reduce the total cost of ownership of the mainframe platform. So therefore, observability from an end-to-end perspective is really key to see who is calling into the mainframe and how often, and where the hotspots are inside the mainframe applications, not only Kix IMS, but also Java on COS. And when you talk about OpenTelemetry, of course, that's a big topic as well on Java on COS. So it's important to create spans to capture span attributes, or if a certain end-to-end observability solution does not support certain protocols, to also provide or do context propagation to achieve that end-to-end visibility from the front end into the mainframe backend. So yes, OpenTelemetry plays an integral part. I recently worked with a customer who changed their code, added the OpenTelemetry code to capture some additional attributes, which allows them to find additional information in some other sources. And the key aspect of OpenTelemetry, of course, is that there's no vendor lock-in. So organizations can use it with our solution, with Dynatrace, but they can also send the data into other platforms. So OpenTelemetry really plays a more and more important part on the mainframe as well.
Do you see OpenTelemetry also go beyond Java on the mainframe? Do you see it's being even considered by IBM to be put into some of the other languages and runtimes, or is this doesn't make sense for them?
I don't think so, that this is a big topic for the traditional workloads, because it's native code, COBOL PL1. From a technology standpoint, I assume it's not that easy to provide something similar that we have for Java with OpenTelemetry.
Okay, that's good to know.
It's interesting too with another point with the OpenTelemetry, I think, is, and this is probably not as much of a concern today as it was even a few years ago, obviously with the more modernized workforce and some of the innovations. But I know when I first started in Dynatrace, 2011, there was a lot of the talk around mainframe was people like, I don't want to touch the mainframe. I don't want to breathe on the mainframe, right? Because one wrong thing and it's going to fall over, right? But even sticking with that fear, which probably is a lot less these days, again, if you get the OpenTelemetry instrumentation into what's running there, you don't have to touch it again, right? So that's another benefit of if you're going to swap out different things like, hey, we'll do it once, we're done, we can keep your hands off and not worry about, this supposedly fragile system, which probably is not fragile like it used to be.
Yes, definitely. That's an important point that you make. Probably for existing applications, it's not that easy to add additional code. Of course, it depends on the importance, but for newer developments, why not add it right away to be fit for the future? So adding OpenTelemetry to a new framework that is being developed definitely makes sense. And That's also what I see with customers. If they make new developments, they are, I would say, very motivated to add OpenTelemetry code. It's easier for them to do it with applications that are still under development or only small web services that they are developing, just adding that code to be fit for the future, wherever they want to send it.
Mm-hmm. Christian, a little focus or explanation, not on the future, but a little bit on the current state and the past, because obviously, right, we work for a vendor, we work for Dynatrace, and we've invested a lot of years in our technology to actually get insights into the mainframe. So what type of insights and observability does, for instance, our agent get on the mainframe that you would not get, let's say, through OpenTelemetry or other means? What is the specialty that we do?
The specialty is that we place agents inside the mainframe applications for the different technology stacks. Could be Kix, IMS, could be Java and COS, Web Application Server, Liberty, but also C Linux. So if customers run Linux on the mainframe, they can place agents there as well. And if they also place the agents on the Open Systems hosts, they will get end-to-end visibility automatically. So just by placing the agents there, the magic is done under the hood by Dynatrace and will provide end-to-end visibility. And when it comes to the mainframe, we provide, of course, the same metrics which are important for mainframe customers, response times, of course, CPU times. So it's possible to record the CPU times for each single transaction. So it's easy to identify the hotspots inside the mainframe applications.
Cool.
And on top of that, of course, failures are always an important topic. So these ones are recorded as well. If transactions fail with data exceptions, for instance, when talking about Kix transactions, the famous ASRA events, these ones are captured as well. And not only do you see these failures inside the mainframe transactions, you also see the impact on the actual users because of that end-to-end visibility back into the applications. And it's a big difference if only one user is affected for an internal application in opposite to thousands of users countrywide are affected in a business critical app.
Yeah, thanks for that insight, because we try to keep this podcast always very neutral to individual tool implementations, but Dynatrace is in a unique position thanks to also the work that CompuWare back then obviously did on the mainframe, and then with the acquisition we brought that visibility and observability into the Dynatrace platform. That's just great to know. Christian, Brian and I often, when we talk about performance engineering, we always love to talk about sort of common problem patterns, right? We always like to talk about, what are the classical things that then go wrong? And then if you look at it and it's like, of course, right, this is always what we see. Do you have like some use cases, some examples of what are the classical things that actually either make the mainframe slow or expensive, or just, where you then do firefighting and trying to figure out what's wrong? What are some of the common things we see out there or you see out there?
Yeah, the common things are, of course, response time degradations inside mainframe transactions for different reasons. Often DB2 plays a role there because indexes are not designed, I would say, perfectly, or wrong indexes are chosen by DB2. But not only that the response time degrades in certain transactions, it's also key to see the impact on the distributed services. I worked with a customer. They really saw performance degradations when a certain amount of users was reached concurrently in a business critical app, and they had no clue what was the root cause. And by testing it out, it was clearly visible immediately. So they increased during a load test the number of users, and at a certain point in time, the response time degraded. So that was already with 30 users. And the reason was a deadlock in DB2. So with that end-to-end visibility, they saw it immediately that this deadlock in DB2 was then the root cause, because multiple transactions were trying to access the same data, the same pages in DB2, and that was effectively causing that problem. You see the deadlocks in DB2 also on the mainframe itself, but you do not have that visibility where it is actually caused. So often it is not even noticed. Well, it's noticed, but somebody says, unless someone shouts out loudly that there's a problem, let's forget about that minus 911, as it is called, this deadlock in DB2. So this end-to-end visibility is key again. Another problem pattern, of course, is high resource usage on the mainframe. Can be in traditional programs where certain information is picked up wrongly or redundantly, so that there are hotspots in programs. So that is also a problem pattern that occurs frequently. What else? Also, that visibility, who is calling into the mainframe. So I also had a customer, they had no clue why the number of mainframe transactions was so significantly increased in 1 year, because they had no context between mainframe transactions and open systems world. And with the end-to-end visibility, they saw it immediately. Well, on the one hand, of course, new applications hit the mainframe, but also the existing applications had more and more users, and therefore they were triggering more and more mainframe transactions. Also, introduction of mobile apps, of course, spread the mainframe platform. You have your mainframe actually in your pocket. You go to your banking account, look at your account, and maybe you pay something that you have purchased, a travel or something else, and on the back end, you hit a couple of mainframe transactions. And maybe not only one or a couple of mainframe transactions. I worked with a customer that identified that with one single click in the browser, they were triggering hundreds of mainframe transactions, and some of them even redundantly. So they reacted really quickly and made this more efficient to reduce the number of mainframe transactions that are being triggered. So these are the common problem patterns that we typically see out in the field.
I wanted to ask with the costs of mainframe, right? And this is where obviously my knowledge is going to fall apart. I know it's somewhat transactional based. I forget if it's IOPS or not. And is that the same as per transaction? Because, and maybe you can explain this, right? So where I'm going with this is the idea that not only is it the performance that needs to be looked at, but more so than in the cloud, there's a direct cost to that performance. So whether it's the amount or the amount of compute you're using, this is how customers at least used to get charged for mainframe. I imagine that's still the model. So is there, if that's still true, is there a balance that needs to be made between response time performance and compute performance in order to keep costs down, maybe at the cost of a little bit of a slower transaction? Like, how does that all come into play? Because I imagine that would be something in certain cases important to look at.
Yes, definitely. That's still one of the most important topics on the mainframe to save CPU cycles. So every CPU second that you're using, especially at peak times, is related to additional cost. On the mainframe, you're typically charged for MSUs, not only by IBM, but also by other vendors. In the past, and it's still widespread nowadays, you're charged for the peak of the 4-hour rolling average MSUs on the mainframe. So that is normally for financial organizations. It's the first time of the first day of the following month, where there is the peak usage for month-end processing, and 1st and 2nd of January is even worse, because then you have all that year-end processing. So that is really massive concerning a peak consumption, and customers are charged for that. But IBM has already acknowledged that this is an approach which can be streamlined as well for making the mainframe platform more attractive. So they are offering also a tailored fit pricing for a couple of years now, which has the effect that you pay for actually used MSUs. So they are charging for MSU hours when customers choose that tailored fit pricing. And that is, of course, more attractive, because you really pay what you are using, and you're not paying the peak value in a month, which is, I would say, a little bit unfair. Because you're paying for the peak and not. You could have a very solid MSU usage throughout the whole month, and at one day you have a really high peak, and you're paying for that with the traditional approach. But with the newer licensing, which we will offer as well very soon, so that is to come this year, we will also charge for MSU hours.
Cool. But I imagine, though, the challenge then becomes not just looking at, like, let's take the classic Andy and I's, one of our favorite problem patterns, right? The N+1 problem. Typically, you don't want an N+1 problem in standard programming. When it comes to mainframe, then I imagine the challenge would be, well, let's try with and without N+1 and see what the trade-off between cost and performance is, because if it's going to cost us significantly cheaper to run the N+1 for some reason, I don't know why that would be, but if that were the case, I mean, I think with the observability and performance in mind, you might not throw out the old performance patterns. You'd probably want to do a little bit more investigation first to see what that cost performance ratio is. Whereas in standard non-mainframe computing, oftentimes the compute is so much cheaper. They don't, most people, we talked about the $4 billion. I can imagine that be auto scaling cloud costs at some point, right? But it's a lot more, right? So would it be fair to say that we can't just ignore or adhere to not following or not avoiding the old performance problem patterns, because they may, in fact, in some weird case, lower the cost? Or do we not find any correlation between it? Basically, if it's good for performance, it's typically good for compute. And I don't know if there's a known correlation or if it's something that people have to test thoroughly on that stuff on mainframe.
Yeah, of course, you need to test that, of course, but there's not necessarily a correlation between response times and CPU cycles. So you can have slow running transactions which are not using a lot of CPU because they are waiting for something, for some resources that are locked for whatever reason. So there's not always a direct relationship between response times and CPU cycles. But yes, with observability, you have the possibility to make comparisons between different scenarios to see the impact of certain things.
My maybe take on this, because Brian, I'll try to figure out if I could come up with a use case where inefficient algorithms would still lead to more cost-effective execution. But I think in general, it's hard to imagine anything like this, right? The N+1 query or anything else means you have more round trips, more data to fetch, and eventually you need more compute to process the data that comes in batches. And therefore, I think that general advice should be optimize your code. The question is, if it's old code, right? If you don't have the resources, it takes really long to get that code change through. And how much does this cost versus the costs that you have? Because maybe that function is only called twice a month. Who knows, right? I mean, that's
I'm just thinking of the processing gets put to a JVM running in an EC2 instance instead of it being put into the kicks or into the database to gather up the large chunk. Yeah, I don't know. It's this is all academic, thoughts, but it does raise this question of cost of operation is much more of a thing on mainframe, and that is a performance consideration. I mean, we always talk about the cost of performance in regular cloud, but I think it's a lot more of a focus on mainframe.
Christian, one thing that you brought up earlier, and I think this was for me, it's almost like an eye-opener, because you said with building new apps and bringing use cases to your phone, you're completely changing the data behavior. Because I may have gone in the old days, 20 years ago, I may went to the bank once a month. Then maybe I went to the ATM to check my balance maybe once a week. Now I can do it every hour in case I'm waiting for something, which means
every second.
Every second, right? Because we are providing services, convenient services to our end users. They have a different behavior now, but it still hits the same backend. And I think that's a really interesting thought that system architects, or also whoever designs new apps and use cases, they need to keep in mind, right? And I guess there's ways to counteract this. So you can put a cache in there, because if I refresh every 5 seconds, you know what, that's what it is, right? And I get some old outdated data. But it's really interesting. Yeah,
correct. So caching, of course, is key here in that context. Yeah, but it's a real issue that you have to take into consideration. So checking the balance by just refreshing inside your mobile banking app, and if you every time trigger hundreds of transactions, that makes no sense. That always get the same data back, and that can be streamlined, of course, but it's important to do it. If you don't do it, it can be a real issue.
Yeah.
So if we don't like our bank, we should refresh our balance a bunch.
Open up a bank account on the competing bank and then just kill them with the costs on the Hey, Christian, I kind of getting to the end here, because we're running a little bit close on time. I learned that the mainframe has been around since 1964, right? April 7, a date to remember, April 7, 1964. Quite impressive. This has been, I wasn't born back then, and I guess many of our listeners have not. So Yeah.
But I was close.
Okay. We have, I know, a lot of resources. You did a great job in preparing for this podcast. You brought a lot of links to articles, blog posts for the Dynatrace community out there. We have different videos, observability clinics, also blog posts with case studies. So we'll put them all into the description and the summary of the podcast, so you can follow up in case you're interested in more. Christian, is there anything else that we missed? Is there any other topic or any parting words where you say, this is what I wanted to get off my chest in this podcast that we didn't discuss so far?
No, I think we covered everything which is relevant for an introduction to mainframe and what is important nowadays and how it has evolved over time. So, yeah, it's still important, and it's still important to get observability into these apps, as the mainframe platform is really business critical.
Brian, what did you learn today?
Well, I learned several things, but the one takeaway, right, Andy, we always, at least in the past, we used to talk a lot about leveling up, right? And, looking at some of this other information that Christian sent us was the bigger industries that will leverage mainframe. I'm just going to read it from the slide: banks, insurance, healthcare, airlines, retail, car manufacturing, government. Sure, there's others. But especially if you work in those areas, you may be writing system components that are interacting with a mainframe somewhere down the line. So it's a good thing to maybe ask around, hey, do we have mainframe? Maybe talk to those mainframe folks, find out how you're interacting with that mainframe, even if you're not directly. Maybe it's something down the line. But it also give you a chance to meet some mainframe people, learn a few things about mainframe, and grow your knowledge, but also grow your value, level up. And mainframe what's amazing is that the use of it keeps growing. And when you think about things like ChatGPT and all these others, with the processing power that mainframes have and the speed and the compute, it's hard to imagine, this, depending on what side of the fence you're on, utopian or dystopian future where computers are semi-sentient without some sort of mainframe involvement, because of the scale and speed that they would have. So it's, and I'm not taking it from that point of view, but just to illustrate the fact that the immense power in these. Now, again, will quantum computing, surpass this if that ever becomes a reality? That's, feasible. Who knows? But it's definitely out there. It's definitely important. And it's just a great reminder that no matter how old or outdated we think something might be, it's probably just because we're ignorant of how it's being used, because it's not the fancy, sexy new language that's out there, right? So what's old is new again. And really, really thank you a lot, Christian, for bringing this topic to both Andy and I and our listeners as well, because we love learning, and that's what we're doing today. So thank you so much.
Thank you. Yeah.
Cool. Thanks for having me.